So in today's Learn With Us series, we're going to hear from Pavel, the author of Fastnet Mon, who's going to talk about the challenges of DDoS detection and traffic visibility for IXPs. So with no further ado, I'll hand it over. Thank you, Pavel.
Hello everyone, I'm Pavel Odintsov from FastNetMon project, and today I will talk about challenges of DDoS detection and traffic visibility for internet exchange points. So you may find many contacts and many ways how you can contact me. All the time I'm very open for sharing my knowledge, learning new things, learning more about your specific cases. So if you have any ideas and if you would like to discuss something with me, all the time, use any contacts. I will be happy to talk with you. So we are going to talk about DDoS attacks. And DDoS is a very complex area, and many industries they use very different meaning what DDoS attack is, because DDoS attack just means actually denial of service attack. It may be some very sophisticated software payload called like commonly known as virus, or it may be some well-coordinated attempt to destroy some service or overload some service using many different approaches. In this specific presentation, we will focus on a network DDoS attacks. So everything is only about network. Let's keep away different ways how DDoS attack against a company or government can be implemented. In this presentation, we'll focus only on network things. But if we even focus on network DDoS attacks, it's still quite complicated because we have many ways how attack can be implemented using network protocols, because now everything is network. And let me start from small introduction, like what kind of network DDoS attacks we are going to discuss in this presentation. So on this slide, you may find out protocol headers for old protocol called IPv4. So you may find out like we have lots of different fields like version, total length, fragmentation flags, time to live protocol, destination address. And from this perspective, I think it's one of the best ways to explain for what kind of DDoS attacks we are going to expect and what kind of DDoS attacks we are going to discuss in this presentation from network side, just to explain what we can change in this specific header. And from perspective of attacker side, bad guys, they can literally change almost everything in this header. Like, of course, we can attach section called version, but everything else can be forged, randomized, used for different ways how it can be used for attack. So TTL field can be easily changed. Even like checksum field can be changed, because for some equipment, if you create enormous amount of packets with broken checksums, it may cause some degradation or trigger some unusual paths in the network equipment. So literally any field in IPv4 protocol can be used. So that's what we're going to discuss. We're going to discuss level 3 DDoS attacks. But what about more modern protocol, IPv6? So on this slide, you may find out what is the header of IPv6 protocol. It indeed looks way simpler. But does it mean that like attackers cannot use? Does it mean like IPv6 offer any kind of security against of using it for DDoS attacks? Unfortunately, it doesn't. So again, we can change, malicious actors can change traffic class, flow label, payload length, next header, hop limit, source address, destinations in any ways how they want. So again, we will talk about L3 attacks using protocols IPv4 and IPv6. And a little bit, we can move a little bit deeper, because we also can cover topic of L4 attacks. When we're talking about L4 attacks, most commonly it means that like we are going to talk about UDP protocol and TCP protocol. Let's keep UDP protocol outside because it's really simple. It's just like source port, destination port, That's literally everything. But again, in UDP protocol, all this information like source port, destination port, it can be changed, it can be forged, and it can be used as attack vector against your network. But what we can see for TCP, we can see lots of fields, again, like destination ports, source ports, sequence numbers, window size, checksum, again, some data. And unfortunately, bad guys can use every single field here too. Every single of them, like specially crafted window size, fine, very common attack type. Some reserved fields, maybe in some cases, just to confuse DDoS detection equipment. So that's literally what we are going to talk. We are going to talk about L3 and L4 attacks. Everything out of it, I mean deeper, like levels 7 or something maybe even more complicated, built on top of level 7. It's out of this conversation. So let's mention, describe it attack types as well-known names. Unfortunately, DDoS attack naming is quite complicated because sometimes it doesn't explain what kind of packets you may expect in DDoS attack, because sometimes people can use like marketing names like Mirai attack or Memcache attack. Like, what does it mean? It doesn't explain anything. That's why I prefer way simpler terminology, which actually just means flood or amplification or fragmentation, because at least in this case, we can understand what we may expect in the output of TCP dump command or Wireshark command or some commercial traffic monitoring search, but at least we can convert name of attack, like it's spoofed source attack. What does it mean? It means that like something happened with source port. On the left side, you can see some dynamics about number of peak performance of attacks. You can see great peak in 2021. It's about 300 gigabits. It's enormous attack, and it may pose danger for almost any kind of network. Even for largest networks, they may be hurt by this scale of attack. And on the right side, again, in the well-known terminology, it's mostly still the largest dangers, flood attacks and amplification attacks. That's what we are going to talk in this presentation. So most dangerous and all those attacks, they can be explained in terms of L3 and L4. And as a consequence, we can see them from Internet Exchange point or transit provider's perspective, which is great. So because we don't need any very complicated equipment, we just need some basic traffic analyzer, and we can find out like which host is a target, which host is a source of attack. And those numbers will finish on Q2 of 2021. What about summer? For this slide, I use data kindly supplied by DDoS Scribing Center and transit provider called Facility. Again, they provide very precise information because it's extremely important to have so detailed information, because you can see it's not about even quarters, it's about days. And you can see peaks up to 1 terabit. It's actually impressive because for some networks, it's their like total capacity way smaller than 1 terabit. And what we can do is everything else. And for now, I would like to ask you for some feedback. May I have question number 2? I would like to ask how many attacks you experienced for last month? Because it's unfortunately it's when I actually called this slide DDoS weather, it's just to highlight that, you cannot say for sure, like for next month, we can expect increase of DDoS, or we may expect some more attacks coming years. It's all the time, unfortunately, only one dynamic we can't say for sure. It's getting worse and worse with every year because of increasing capacity, more connected devices. But that's only thing we can say for sure. If somebody was to tell you, like, for next month, you may expect more attacks, you know, all the time it's more like speculation. We may find out like what kind of things may trigger more attacks. You may actually expect a lower number of attacks during summer months. It's quite common observation because lots of people on vacations. But actually in 2020 and 2021, it's quite special years and many things changed. and dynamic of like total quiet period of like summer vacation, it didn't happen. It's still not just lots of attacks, and you can see it from numbers supplied by Vexility. And can we see results from my question? So you can see we have lots of people actually who experienced more than 5 attacks. It's quite sad dynamic, but it means that like it's more part of your day-to-day jobs, like 5 days from like about 20 working days per month. It means actually you have DDoS attack on every second day. You know, it's like more like business as usual than something, oh, it's something, something impressive, something which never happened before. So we need to deal with it. What we can do? We are going to discuss DDoS attack detection in terms of internet exchange points. And for my presentation, I selected one of the largest internet exchange points. It's Moscow Internet Exchange. They were so kind to share so much information with me about like what's their peak capacity, what kind of attacks they experienced. And I would like to use them as, you know, as showcase what we can do and what kind of dangers we may expect as being internet exchange points from DDoS attack. And you may see peak performance of Moscow Internet Exchange. It's around 4.4 terabits per second. Again, on for previous presentation, we confirmed that one of the largest attacks which happens is 1 terabit. Like in context of almost 5 terabits, can't we notice 1 terabit attack here? We'll definitely will. And the next question will be how much traffic, for example, Moscow Internet Exchange can absorb. Like for now, we have average numbers, but those numbers can be changed. For example, somebody will find out new vector of DDoS attacks. And then we'll be in position of something very dangerous, very massive. And then we may expect like maybe something will degrade. What will happen? And to answer this question, we need to find out what is the total current capacity of Moscow Internet Exchange. Let's find out. I opened the Moscow Internet Exchange site, and on official information, I can see 8 terabits. Sounds impressive. It's actually, we can double load on Moscow Internet Exchange and it don't miss anything. It will be just business as usual, nothing special, no degradation expected. But, you know, is it like up-to-date number? Because sometimes information on site may be not very fresh. That's why I reached Moscow Internet Exchange and asked it for details. What is the current capacity? Like in terms of what is current capacity, how much traffic they in theory may absorb if they can summarize perform like capacity of every single link available for their switching platform. It's 152 terabits. Can you imagine it? Like it's like not 2 times bigger. It's even not 10 times. It's like way bigger than like tens and tens and tens enormous DDoS attacks. And you can see no degradation expected in this case. They have enormous amount of spare capacity. It's hard to say for sure that it can be applied for every single exchange available on market. But in terms of like modern switching platforms, they have enormous capacity. And for example, Moscow Internet Exchange, they're doing tests for 400G platform right now, and they're waiting for some customers who actually have interest in 400G platform. But what they're doing, their current platform and testing for 400G, it's 8 ports by 400 gigabits. Again, it's just single switch which can process almost everything they have in peak time for wall exchange. And having this kind of exciting equipment, network equipment, it puts us in like few steps forward than any kind of enormous DDoS attacks bad guys can create. So we're in great position. And what is the problem? what we are going to talk, what we are going to discuss in this presentation. And is it really dangerous for internet exchange point to have like attack? It's actually very unlikely. And because all the time, internet exchange points, they have lots of spare ports not used by customers, and modern switches are coming from vendors frequently, and they increase it. Like in like last few years, migration from 100G, 200G, 400G, it's happening very rapidly. So from internet exchange point, it's not a big deal. But does it mean that we will not experience any issues from this perspective? Let's look from a little bit different perspective, because what is the main point why we have internet exchanges? Because internet exchange is just point of interaction and network interconnection between all customers. What is the problem? Problem is, let's start from small conversation. What is a typical setup for medium or small internet service provider? It doesn't matter where is this company located. It's quite common. I had some survey from people from different parts of planet, very different parts of planet. I asked them, what is a typical formula about interconnectivity? Like I ended up with something like 2 transit providers, mostly for redundancy, and around 3 internet exchange points. I did not name them anyway, because, it may be in South America, it may be in Asia, it may be in Africa, it may be in Europe, in States, whatever, Australia, it doesn't matter. It's quite common scenario. And again, we confirm that internet exchange point itself is not in a danger. But what will happen if somebody will start attacking this small ISP from internet exchange point 1? Okay, what we can do is, let's imagine that company has no DDoS detection and mitigation equipment in place. Unfortunately, it's common, because we still have lots of companies never experienced DDoS attack. But what we can do, we just have bare minimum. We have routers, we have switches, and we have smart network engineers. And then we noticed that one of the links from IXP number 1 was filled by some weird malicious traffic. What we can do? Simple, de-period, unplug cable, and keep moving. And is it bad? It's not terrible, because for some period of time, all traffic will move away to transit 1, transit 2, and IXP2 and IXP3. And from this perspective, let's talk about large numbers. In internet exchange points, they process enormous amount of traffic. But one of the largest contributors to many internet exchange points, it's caches. They may be caches from Google, Facebook, many Akamai, many cloud providers, they have caches. And bandwidth, which can a number of caches which can be reached not directly from company, from ISP, but over internet exchange points, it's extremely large. So by cutting IXP1, we literally cut cache number 1. It may be YouTube, and YouTube has enormous capacity. What will happen next? You can see I explicitly highlighted that we have no connectivity to cache number 1 from IXP2 and IXP3, because, what is the point to have many internet exchange points connected to same cache? And what will happen with traffic? Traffic will move away to transit number 1. And here you go. At this point, we may start experiencing a problem, because, cache 1 may be in your town, or at least in your country. But when you move away from it, traffic can move on to opposite, at least same continent, or maybe very far away place from your country, and then your customers will notice some degradation. Okay, but we kind of solved the attack. It's not downtime yet. What will happen if we experience DDoS attack? Because again, DDoS, it's just name of it, like distributed app. It's very unlikely that you may experience attack from single internet exchange points. Bad guys can do it from many of them. Let's imagine we lost every single internet exchange interconnection. Fine. We still have transit providers, two of them, for redundancy, as everyone must do it. Like it's proper, it's best practice. But typically, I had quite long conversations with many of my friends from ISPs, data centers, and one of the things from ISPs, they have more traffic, more bandwidth coming to internet exchange points than to transit. For Europe, this number is around, like, of course, it may be different, but it's around 60% of their traffic coming to caches and internet exchanges and 40% to transit. But of course, all the time, companies must have a spare capacity for transit 1 and transit 2. Fine, we can cut every single available cache and cut connection with all internet exchange points. Fine, we can move forward. We still can offer service, but our customers may start yelling on us, like, what's happening? We have lots of like delays. YouTube is not working fine. Facebook sometimes fails to load my favorites, and I cannot post my favorite dish into Instagram. Disappointment, sadness, frustration. And also your management may be very frustrated too, because typically, even if you have great agreement with your transit 1 and transit 2 about like some ways that how you can exceed your prepaid amount of bandwidth, and for keeping it long time, let's imagine long-term attack, you may exceed your allowance and you may need to pay more to your transit providers. So you can see we may handle DDoS attack in some ways, like moving traffic away. But one of the main points, for example, for ISP to offer reliable and fast service to content providers. And by moving everything to transit, we degrade their service. It's not great. It's still not good. It's not like big degradation, but still it's a way less more cool. Actually, the quality of service in this case will be worse. And also, your transit 1 and transit 2 may be under DDoS in the same time too. So, and during time when you actually depeer with your internet exchange points, again, you need to do it manually. Like there are no automation in place. You have no magic boxes. And what we can expect for a company which is well prepared for this kind of circumstances, because, for example, when we cut every single internet exchange points, attack may start coming from transit 1 and transit 2. And in this case, we will not have simple option how we can cut it. So look, what changed? You can see we actually added few small images of firewalls for transit 1 and transit 2, because for transit providers, it's not uncommon to have DDoS filtering and mitigation as part of their service. Like you may pay like some percent on top of your transit cost, and then problem with DDoS or with this specific link will be handled automatically by provider. They may have special equipment, or they may move your traffic to cloud. It's their area of problem, and you can eliminate yourself from this. But again, even if you pay for DDoS detection and filtering for transit 1 and transit 2, you cover it, but you cover it only from bottom side, because you still need to have connectivity to internet exchange points, because just, you want to save on their fees because they charge you more. And options to have connection with local internet exchange points to reach local caches, it's great benefit about latency. Why not? And then you all the time, even having DDoS detection and filter in place from transit, you still need some magic to plug in and plug internet exchange points. Again, hassle. How it should be. On that diagram, we are talking about ideal world. And it's one of the things we need to move forward. And in this case, if we have some ways, at least to detect attack, or maybe even filter it out from internet exchange points, you may say for sure that we don't need all this magic moving of traffic from like internet exchange point to trains, nothing. It just magically works. And that's one of the things we need to move forward. And if company really cares about quality of their service, and they really want to avoid hassle of waking up in the middle of night somewhere in Christmas to fix and move traffic away from internet exchange point, like just to push every single prefix using transit, like to infiltrate DDoS attacks consequence, if you want to avoid it, then you may need some assistance from internet exchange points. And internet exchange points in extremely great position how we can help customers. So at this point, I would like to have small question. Question number 1. In this question, I would like to ask how do you have any kind of traffic visibility deployed in your network? Under terminology of traffic visibility, it means some service which collects traffic from your network. It draws some graphs, nice diagrams. It creates reports about like dynamic of changes in your network. But from perspective, if something really weird happens with your network, or actually some of your customer reported some weirdness which happened like 1 week ago, for example, a few days ago, and you cannot look on it like open, you cannot open TCP, you cannot open your configure like statistics of your counters on your specific switch or routing platform. You need some place to retrieve this data. And may I have results? That's impressive. I actually did not expect it because I was well prepared, like to have a long story, but you need some kind of traffic visibility. It's great results. You make me happy. So it's really great because it's one of the first steps which are really crucial for DDoS detection. So, because transit providers, ISPs, data center cloud providers, they're all very different. And in this presentation, we are talking about internet exchange points. I used great information supplied by project by ERX about IXP database. It provides lots of great information about like how many ports we have, what is the country of the specific internet exchange points, and most important, what's the equipment used by internet exchange point, because sometimes it's quite complicated to find out what's like most popular switching platform among of internet exchange points. And so I did some data digging, mining, and I couldn't confirm one of the most, of course, almost every exchange point uses switches. And when we're talking about switches, one of the most popular ways how we can actually retrieve traffic from them is S-flow. And by coincidence, S-flow is one of the best protocols for DDoS detection. I had different presentation to cover only protocols which are best for DDoS detection. But, conclusions from my last talk was just very simple. S-flow is the just best one. S-flow is a very simple protocol. And if you had experience with protocols like NetFlow or IPFix, you may expect they're so heavy on hardware. Or sometimes you may need to pay for additional modules to implement it, or you may degrade performance by enabling it. But it's not the case for S-flow. It's very simple. It provides lots of information. It's very simple for switches, routing platforms, and considering that we are living in a world of where 100 reports is common stuff, it's even more important because performance of overhead of telemetry solution just to retrieve and capture as much as possible information about traffic itself on such enormous speed, it's challenging. And in S-flow can do it very well. So at this point, we're in a great position. Almost every single internet exchange point has support for S-flow protocol in some ways. Does it mean that like S-flow can be used only by internet exchange points itself? Like we receive it, we store it, we use some graphs. Yes, it's great, but internet exchange point, again, it's network interconnection. And one of the best things I saw, it's like project by internet exchange points, DESIX, and they have great project to not only use as network telemetry for their own purposes, but also they can export it to customers. Why it's important? Again, so on this presentation, we have like great coverage about having network telemetry in their networks, but not every single network has any solution about traffic telemetry. And if inter-exchange points can share some graphs, for example, again, you're in positions that you observe some weird traffic coming from internet exchange point. And instead of just, let's cut it down, you may open their portal and find out like, we have strange spike of UDP traffic coming from port 53, and it's mostly fragmented. You're in way better position to defend it. You may apply ACLs, you may use BGP flow spec to filter out some traffic instead of just cutting it down without any explanation. So it's a great project. And if you have plans about enabling telemetry for your own purposes, for your own exchange points, think about maybe as next step to expose it to customers. It's maybe very beneficial for them. And from this point, we reach a position like we have some way how we can actually retrieve network telemetry information from internet exchange point. I mean, in these terms, like switching platform or just like. And let me introduce my project called FastNet1 Community. FastNet1 Community is open source project for DDoS attack detection. It mostly built to deal with L3 and L4 attacks using protocols IPv4 and IPv6. So from FastNet1 offers great way of automation, which is also extremely important for internet exchange point, because in many cases, it just switch in the middle of nowhere, and you cannot have people studying on graphs, diagrams, and clicking button, approve this specific mitigation, provide more information for DDoS detection solution. No way. FastNet1 was built to just, back in time, it was built to save my own night sleep, to avoid waking up in 2 a.m. and with red eyes trying to understand what's going on in my network. Why they woke me up again? So why life is so sad? FastNet1 is built exactly to avoid this kind of situation. So it offers great performance of detection. It can detect attack in a matter of seconds. It can apply some actions. I will cover them a little bit later. And then without any interaction from your side. So sounds promising. Should you try? You still have doubts? Maybe it's not interesting. It's boring. Look at those graphs. We just pinned every single known installation of FastNet1 across the planet. And you can see issue with this graph. We still have gaps. You can see we have some gaps in Russia. We have gaps in Africa. And from left side of South America, we still have gaps. And if you haven't tried FastNet1, try it and join the enormous community of happy FastNet1 users who actually sleep very well in their night shifts. So if you are not impressed and you're like, maybe this stuff works in some kind of weird environment, no way. FastNet1 works on almost all possible platforms you may imagine. But it's mostly Unix-specific platforms, but it's not limited by a list of operating systems on this slide. You actually may run it in Windows Linux subsystem, which will work. And we just recently received one of the quite successful stories from one of the FastNet1 community users, look, it works fine. So even if you use Ubuntu, Debian, Red Hat, or all kinds of Red Hat Linuxes, you can use FastNet1 and deploy it in a matter of minutes, I would say. Again, if you're not impressed with this map, with many customers, again, it's list of supported vendors, and for every single logotype, it's not just random logotypes. It's like every single logotype. Behind every logotype, we have hundreds of installations of FastNet1, hundreds of successful installations of FastNet1. And from our perspective, it's not a great challenge because we just try to follow all standards on protocol implementation according to specification. And if vendor implements their telemetry and BGP well enough and according to every available RFCs, then it will work with FastNet1. So if you cannot find your favorite thing on that slide, it doesn't mean that it will not work. With guarantee of 95%, it will work. Just try it. In terms of detection time, again, you can see I mentioned like SFlow, one of the best protocols. Of course, we have a little bit better numbers for case when we receive traffic from port mirror to some Linux boxes. It's typically common, known as port mirror or span or remote span or tap. It's 2 seconds, a little bit faster, but of course, considering capacity of internet exchange points, like, all this crazy stuff about 400G, you just cannot copy every single packet of traffic to your server. And for real applications, of course, we are going to select from NetFlow and SFlow. So we can see even for NetFlow, FastNet1 offers very decent time about attack detection, which is also extremely important. FastNet1, in addition to SFlow, FastNet1 supports NetFlow, almost all versions of it. Like, of course, we support samplet NetFlow, samplet IPFix, all kinds of strange encoding. So we trying hard to add every single available way to retrieve traffic from vendor side, because for some cases they just work better, like faster, introduce less overhead from equipment side. So scalability. Don't be scared by the diagram. It's just numbers. We know for sure they were reported by our customers. Again, considering crazy numbers from Moscow Internet Exchange, like around 5 terabits, it doesn't look impressive, but it doesn't mean that FastNet1 cannot handle it. Try it, and if you notice any issues, we will help you. But according to our FastNet1's design, you just may need to have more powerful CPUs, allocate more memory, and then FastNet1 will handle it very well. So, and if you have better numbers for your existing deployment of FastNet1, report it to us, and then we will update them. But again, 1.2 terabits, it will cover most of the internet exchange points from IXP database, which is great. What we can do when we're talking about DDoS detection and mitigation, mostly it means that we need, when we actually detect an attack, we need to apply some actions. And in terms of FastNet1, we have we do our best to support ways which are more friendly to network engineers. And of course, most convenient way to share some actions or routing changes or rapidly on your network is BGP protocol. And we support BGP protocol using 2 different daemons, ExaBGP and GoBGP. My personal favorite one is GoBGP. And if you haven't tried, it's not, related directly with FastNet when we just support them over API. It's great BGP daemon. They have a very nice command line interface. They have very nice API, and it's actively developing, and they have lots and lots of different families of BGP protocols. So when FastNet1 detects attack, it can create specific unknowns using specific community, specific next hop on different boundaries. It may create unknowns for attacked host itself or network which is under attack, which is also may be useful to apply different actions. And if you don't want to make any BGP changes automatically in your network, then you can just call script. And then you can propagate changes or notify your customers, or maybe show warning in IXP manager, which is maybe great again, because when people are under DDoS, they are scared, and if you can provide more information, like we see something unusual with your network, and it may provide very important information, which will reduce time required to mitigate attack. At least a little bit, but still, it's very important. FastNet1 can be deployed very fast. It's not, we don't use Docker, we don't use any kind of compilation. It's not, sophisticated installation process. It's not image. It's just Debian or Red Hat packages, binary ones, which can be installed via a very simple installer script. And why we use installer tool? Because some configuration from Linux perspective, especially from kernel configuration and some few more options, few dependency packages, they needed to be done, and our installer can do it for you. So if you just run it, wait a few minutes, and here you go, it will work. Most of the stuff can be learned by fastnetmon automatically without any kind of your introduction or your involvement, but we still need, of course, we need some information from you. For example, configuration with BGP session, configuration about thresholds, and what level of traffic you consider as dangerous for your case. You still need to do it, but that's literally all you need to change from fastnetmon side. It's very simple. And to install fastnetmon, you just need to follow 3 commands. Our installer tool can handle everything for you, and when it finishes, you will have working installation of fastnetmon. So simple. I hope you will be happy with that. How fastnetmon actually works? From well-known classifications of DDoS detection sensors, fastnetmon is threshold-based sensor, or sometimes it may be called baseline-based sensor. What does it actually mean? That fastnetmon mean baseline or threshold level, and threshold level is a level when a specific amount of traffic will be considered as attack. In fastnetmon, we don't have any complicated validation or logic to confirm that this traffic is attack. But if in your configuration you say that any kind of traffic coming to host /32, which generate more than 100,000 packets per second using protocol UDP, then it will be DDoS. And then fastnetmon will calculate it, and then it will trigger all related actions. It will create BGP announce, it will call your script to share this information to your existing systems. That's all it will done. So it's quite simple. And in addition, we have many different threshold types, maybe for different protocols, different like subtypes of protocol. For example, you can create specific threshold only for SYN packets using protocol TCP, which may be useful just because TCP SYN floods are still very dangerous type attack, and so you can find out and detect them faster. When fastnetmon detects attack, it creates quite large amount of information which can be used and sometimes shared directly with customer. And this one is example report generated by fastnetmon. You may find what kind of traffic was involved in this attack, how much packets we had, how much megabits we had. And you can use this information for decision making, like what you can do, like is it more than capacity we have for this specific client, what can be done, can it be filtered like on port, or we need some special equipment like or cloud DDoS scrubbing centers. It's very important for decision making. And then one of the things which you have for free with fastnetmon, because for fastnetmon we calculate lots and lots of information in memory. Fastnetmon is a real-time DDoS detection engine. We never ever store any traffic to hard drives before we process it. So for DDoS detection, you don't need any way to store traffic. It can work completely on machine without any hard drive, because everything processed in memory. But again, to understand what's going on in your network, it's not enough to just think, okay, we have attack, block it. We need to understand dynamic of attack. We need to understand, and sometimes you may have issues to find out like what host was the target of attack. Is it single host or multiple host? Or maybe it was the worst possible kind of attack, which is coming against whole prefix. And for that purpose, in fastnetmon, we have bundled support for time series database called InfluxDB. And also we support quite old time series database called Graphite. And in addition, we have plenty of nice dashboards for Grafana contributed by our engineers or community on grafana.net. You may find plenty of them. And this one is just example. You may find out like what's your total traffic for protocol IP for T6. It's common. You may find this kind of information from your SNMP counters. But even better, you may have this kind of information on prefix basis. which is, not accessible from SNMP counters. And even better, you may have this information on host basis. Then you can expose this information to your customer. You can ask this. Of course, you may expose it for your engineers, because if you notice some spike for specific customer to their port, and they may reach you like, guys, what's going on? You may open this diagram and look, okay, we have spike for specific prefix, and it will help a lot. And if you can show it to customers in their portal or IXP manager, is also great, because you can see something weird happening here and happening right now. So it will help with those detections. It will help to find out why it happened and what you can do, how you can stop it. So when fastnet detects an attack, it may call a script. That's, you can see, its simplest possible script, which can just send email to your network administrators just to notify them that fastnet efficiently and promptly detected the DDoS attack. But also you can run different actions to propagate it to customers, send messages, pager duty alert, or do whatever you want. So you can see it's very simple. It can be done in Bash, Python, Perl, Ruby, any your favorite programming language. We don't have any constraints about it. As I mentioned, it's every single configuration option you need to set a baselines for fastnet. So on the left side, it's global thresholds. You can see some of them in flows per second, some of them in bandwidth based in megabits per second, some of them protocol specific like ICMP bandwidth, and some of them are more global like bandwidth, which is total bandwidth. On the right side, it's more interesting thing, because of course, in case of complex networks, and especially in case of internet change points, you cannot use same value for everyone. Of course, you can, but more like emergency alert, like when, for example, customer has 10G port, and for some reasons, a single host on their network exceeded 10G, then it's definitely issue. But to create different thresholds for different networks or for different customers, for different ports of the same customer, you can create groups just to add different prefixes, and then you will be able to set different levels of traffic expected for this specific network. So, which is also useful for quite complex environments, and you can create any numbers, and we don't have any limitations. We have great community, because fastnet community, called community for a reason. We have around 2,000 people in all our communities in Slack, in Telegram, in IRC, in Facebook, LinkedIn, WhatsApp, GitHub, and it's great community. And if you face any issues with fastnet, and if you face any problems you cannot solve, I personally will be happy to help you, but I cannot I can help with fastnet questions, but not with common network questions. But we have plenty of people who actually do their great job in fighting DDoS, and they may share specific recommendation for specific platform, for specific ISP in specific part of planet, which is great. So also you can share your experience with fastnet. So join if some of your favorite messaging options is missing on this page, just send me a message and we will be happy to add create one more official page. Thank you for listening to my presentation. Again, you may find me in different social media, and I will be happy to talk. I will be happy to answer questions. And if you have any questions now, that's the time.
Thanks, Pavel, for that really interesting and engaging presentation. It was really good. I think I might have learned a few things about DDoS too.
Thank you for inviting me.
So I see we have one question in the chat, and that is fastnet supports MikroTik vendors.
Yes, we have plenty of customers with MikroTik. So, and actually, you may check my previous presentation from India Network Operation Group, and it was complete workshop how you can deploy fastnet mod and MikroTik from the beginning, with every single step from fastnet mod and MikroTik site documented on video. So Google it, and it's just step-by-step guide how you can actually deploy it on fastnet mod with MikroTik.
Excellent, thank you. Are there any other questions? I see we have a hand up from Mikhail. Do you want to put your video on and audio, or just your audio?
Pavel, hello.
Hello.
Regarding IPv6 protocol, is it still theory, but or we also in practice face with IPv6 attacks, and how large is it?
So I cannot say that like IPv6 attacks are something which happen on daily basis. But from around 10% of our customers, we received report at least about one IPv6 based attack. So it's happening. It's not that dangerous because for IPv6, we still have an option how you can just literally disable it for some period of time or depeer it. But it's exactly the same thing as with internet exchange points. You can depeer it to solve problem, but you need to have some visibility about to understand, because in some cases, if your network is IPv4 only and you just listen to the IPv6 and then you notice some degradation or some spike on your routers, and it will be great to at least, and if you did not face any issues with DDoS, at least to understand that, okay, we have something going on with this specific protocol, and then you may find out options how you can address it.
Thanks.
Thank you. We have another question in the chat. I'll read that out. Once BGP flowstack action is generated, how is it applied on an IXP network, especially when a root server is not involved in the customer's interaction?
It's actually a great question, because it actually depends on design of IXP, and also it's up to every single member of Internet Exchange Point to decide what can be done in this case. And in some cases, from technical perspective, it can some switching platforms, they can filter out some traffic. But of course, in this case, it's customer consent needed to filter out their own traffic. But unfortunately, you may face many limitation of switching platforms. The number of filtering rules is extremely limited, and you can maybe create for large internet exchange points, you may create at least 100 of rules to filter out maybe fragmentation traffic or something quite basic one, but it's still impossible to filter everything. And in these terms, it's more about what we are trying to accomplish at this point. At least we want to have more visibility to understand some malicious traffic is coming from internet exchange point, because it will be a great first step. And I hope in future switching platforms will have more options to filter out traffic actually. And it's happening right now, because back in time, from this perspective, my favorite protocol is BGP flowspec, because BGP flowspec offers great ways how we actually filter out malicious traffic. And back in time, it was limited only by routers. It was available in Huawei routers, Juniper MX series, Cisco ISR series, few models from Nokia. That's all. But one of the great things which actually happened last year, about 1 year, that switching vendors, to be more specific, Arista and Extreme, they added support for flowspec protocol on their switches. And again, Arista and Extreme, they are quite commonly used by internet exchange points. And you may actually use BGP flowspec to filter out specific traffic. But again, it's not only technical problem, it's also problem of policy, because for many internet exchange points, they are in position to avoid any alteration of customers' traffic. And it's one of the things which need to be addressed, like, and decided by specific internet exchange points, what they can do and what's their customers' opinion about like filtering some traffic, because all the time we need to expect like false negative or maybe even malicious attacks in attempt to disrupt the internet exchange point itself. It's exactly the same issue as for DDoS detection and mitigation on transit providers, but it's not that known, but it's exactly the same problem.
Thank you. Are there any more questions for Pavel? No? Okay. I think we're at the top of the hour, so I think we'll close off there. I'll say thank you again to Pavel for that really interesting presentation. If anyone has joined late and missed any of it, the recording will be available on our YouTube channel, and we will publish the information once it is. With that, thank you everyone for joining us in this Learn With Us series, and thank you again, Pavel. We'll hope to see you all next time.
Thank you so much. Thank you for listening. Goodbye, everyone.